Hi guys, I know it's been a little bit, but here we go. We have another car tutorial. Today's lesson is going to be on brakes because as important as going is, I think stopping might be a little more important because if you don't, you'll more than likely die. So let's hop right in. Brakes consist of several parts. There is a master cylinder, a slave cylinder, a brake pedal, a brake servo or brake booster as it's also known, hydraulic lines, brake pads, brake calipers, and brake rotors. Those are the main components. There's significantly less than in an engine where I could probably need more hands to list them off. So let's start off with the main part of the brake, your master cylinder. So this right here is your brake pedal. When you press it, it releases this piston right here and pulls it back. This right here is brake fluid. When this pulls back, it creates a vacuum that this fluid wants to fill into, which it runs out into what this right here is called the slave cylinder, and it pushes these two pistons out, putting pressure on the other parts. It has a spring right here, which returns it back to its normal position when you let go of the brake pedal. And in order to create a more of a vacuum to make pushing the pedal easier and so that fluid goes faster, we have what's called a brake servo or brake booster. This has another piston right here, and this is a little crisscross thing, is like a spring type device that pushes it out and brings it back. When you push on the brake, it pulls backward, which creates another vacuum so that brake fluid, and it usually sits like around here. From the front, a brake booster is also kind of it's a circle, so that's what the little circle thing that's like sits like right in your engine bay is, and that creates even more of a vacuum in order to help brake fluid flow. So now the other stuff. There is a couple of main parts to the actual devices that stop your car. That's the brake calipers, the brake pads, and the brake rotors. So imagine you're looking at your tire from the side of your car. This is what it'll look like. This part what is this? This is red. This is your brake rotor. This hole right here is where the axle that attaches to your actual tire is. This sits behind your tire, and this right here is the brake caliper. So if you look at it from we're looking at a straight on view with the brake. A brake rotor is made out of a semi-metal substance. It's made of metal and different other ceramic and organic materials. Let's say. And how these work is this part right here is turning with your wheel. When you step on the brakes, those hydraulic brake lines, they are sitting like on the ends, and it puts pressure on these. Now these brake pads here, they're also made of some sort of semi-metal and semi-organic material that's squeezed together and push and cause it to slow down. It turns the rotational energy into heat energy. And your brake rotors actually aren't full solid metal. They usually have little slits in between the two main plates, which allow them to dissipate heat. Man, it's hot. It allows them to dissipate heat and get it away so that you could brake easier. If your brakes get too hot, they won't slow you down effectively. So let me make a couple more graphs to help clarify. Let's see. I like green. I just got some new dry erase markers, so I have more colors now. So there is another main type of brake, and these are called drum brakes. I'll draw it out for you. Okay, so now I got this out. These are called, or are called drum brakes. Hey, where did the lid to my marker go? There it is. Okay, so drum brakes, they operate a little differently than disc brakes, which was the previous one we talked about. And how these work here is they have this little device here and this little what would it be called? Like this little device rotates here, which turns this one right here. When it rotates, it turns these things, which are made out of the same stuff as brake pads, but these aren't called brake pads, they're called brake shoes for some reason. It pushes them upward against this outer drum. But we realize that drum brakes are far inferior because this is sitting inside a little metal casing, which means you can't get rid of heat easier. And it's easier to create more hydraulic force squeezing inward than pushing outward. And also, it's attached by a wire to this little device here that pushes them out in the little hydraulic pressure thingy right here. And also, it has like a mechanical spring type devices, and you want to avoid using like springs and stuff because those wear down and lose tension over time. So drum brakes, they're used in like older vehicles like my truck. It has disc brakes on the front but drum brakes in the back. And some newer cars that they don't, if it doesn't go as fast, or you want to minimize cost, you'll use drum brakes on the back and disc brakes in the front. All older cars had only disc brakes on all four wheels. So that is how brakes work. I have one more little diagram, and we'll talk about one last thing about brakes. Let's go here. So when you press the brake pedal down, it releases that hydraulic fluid from the reservoir, and it kind of goes like this. This is your master brake cylinder and the slave cylinder right here, and this is the little area where it's distributed. I don't actually know the name of it, but I think it's just part of the slave cylinder. And one line goes out to this wheel, one line goes out to this wheel, and then the two back ones. And these and there's actually always fluid inside these, so that there's not a delay from the time you hit the brakes where it gets there. There's always just a small amount so that there's almost instantaneous pressure on the brakes when you get there. So now we'll talk about brake pads and brake rotors. There are there's about 3 or 4 different types of brake rotors. There's a full metal, semi-organic, tungsten, and carbon ceramic. Your organic ones is made out of like it's made out of like scrapes of like different non-metal materials. I'm not exactly sure what they're made out of. Honestly, you might want to Google that. Can't find it. Full metal brake rotors are usually cast iron, but it weighs a lot, so sometimes they're made out of aluminum. Now, tungsten is made out of cast iron, but it has a 1 millimeter layer of tungsten, which is the second hardest material next to diamond, and no one's gonna use diamond brake rotors. And this makes them stop extremely quickly, but that one layer wears down fairly quickly, so you have to replace the rotors every about 10,000 miles, and it costs about total $10,000 to replace these. That's why it's only in like expensive high performance cars. And the top of the line brake rotors are carbon ceramics. These materials are both for the pads and the rotors. Now, carbon ceramic brakes are very expensive. They're about $30,000 for all four, which is not something you want. That's not fun. but they're made out of carbon fibers, epoxies, and ceramics. They like chip them up into like little tiny flakes, make them super hot, press them together, and when it cools down, you got your brake pads and your brake rotors. And carbon ceramics slow down super quick because it could dissipate the heat as it's moving better than the other materials. And that's why carbon ceramics are mainly used in race cars. There's not a lot of road cars that have them. So now we're going to talk about brake cooling. I showed you the slots in the middle of the rotor, but there's other ways that brakes stay cool. Because it's a really important part of stopping to keep your brakes cool. A lot of strategies have been devised in order to more successfully do that. So one of the like if you're like a first time car builder who's like wanting to like you want to modify your car and get better brakes for it, a lot of times what you'll go with is slotted brakes. These right here are like holes. It's just a hollow straight hole right through it, and this allows air to flow in and out easier and escape easier in order to keep them cool and reduce brake fade. Brake fade is when you hit them too hard, and as you hit them hard and as you keep on pushing and as the heat builds up, it actually makes your brakes less effective. Oh, there's one more thing that I forgot to say about cylinders. Okay, and then there's another type that is never ever used in road cars, only ever in race cars. And this is drilled brake rotors. Now, drilled brake rotors have a bunch of tiny holes in them, which means you have more surface area, but about the same amount of hole. But there's actually a little less surface area, which means you get result in more brake fade, which is why they're also only used in race cars. Because race cars, you're braking for a shorter amount of time since you're going fast as fast as you can, and then you brake hard. But if you're doing like more gradual braking, this is going to suck. You're not going to slow down very fast. And this is why it's only ever used in race cars. Now, there's one thing I forgot to say. So, the master cylinder is actually bigger than the slave cylinder for several reasons. And this is to make it easier on the driver. Smaller, bigger. Because this is smaller, you're pushing down with enough pressure, but since you're pushing down with enough pressure, it moves the bigger cylinder at the same exact pressure, which means you don't have to put more pressure if you were to have bigger brake pads and brake cylinders. And a lot of cars like have 6 pistons per wheel caliper, which is kind of insane. But no matter how much you do, because the master cylinder is smaller than the slave cylinders, you don't have to put as much pressure in order to get the same amount of stopping force. So if you guys need anything clarified, text me in the group chat, and I'll see you guys later. I love you and miss you.